Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for October 3rd of 2025 is titled Pandora's Cluster of Galaxies. So what do we see here? Well, here we see the cluster known as Abell 2744, and this has been imaged by the James Webb Space Telescope. And this is an example of a galaxy cluster, and in fact a very large galaxy cluster. Most every object you see in this image is a galaxy. So there are a handful of one prominent bright one just to the right of center, and several others around, and you will notice them with their diffraction patterns going through them, caused by the optics of the Webb Space Telescope, and that's how it will image anything that is just a point of light. So there's a few, and if you search around, you might find a dozen or so scattered around the image. The rest of these are galaxies, and in fact the cluster, it looks to be a merger of multiple clusters, and that would be three different clusters here that are then merging into a single, even larger cluster. And this seems to be the way galaxies evolve. That galaxies grow by cannibalizing other galaxies and growing larger, but galaxy clusters do the same thing. That galaxy clusters will group into even larger clusters, and that seems to be what we're catching in the process of happening here. That galaxy clusters are merging together, creating a much larger cluster. Now, not all of the galaxies seen here are specifically associated with Pandora's cluster. Some of these are actually well behind it, and you can note some of those because their light has been distorted. So you will see some galaxies that are stretched out very long and curved into arcs. That is because of what is called gravitational lensing, and that is caused by the gravity of the cluster as a distant galaxy's light comes through it. So the distant galaxy's light is then passing through space and time, which have been warped and bent by the gravity of the cluster. So it is not smooth space-time as we would normally be used to. It is completely deformed by the cluster itself and its gravity. And that means that light is not following a straight path through it, and we will get this kind of distortion. The amount of distortion can be measured, and that allows us to determine the mass of the cluster here. And what we learn, as we learn with all galaxies and all clusters, is that there is a lot more matter present than can be accounted for by the galaxies that we see. And that is what we call dark matter, that all these galaxies and galaxy clusters have dark matter halos around them of a material that we do not completely understand. It is not an ordinary type of matter, meaning it is not made up of the same protons, neutrons, and electrons that make up ordinary matter. And that has been confirmed by various studies that would be able to eliminate that type of material from being in contention as being what is the dark matter. So one of the best bets right now is that it's a weird exotic particle that is massive, has mass to it, but does not interact through the electromagnetic force the way electromagnetic light does. And we only see its gravitational effect, so it doesn't give off any light that we can see, but it does have gravity, and we can see its gravitational effects and measure its presence that way. So that was our picture of the day for October 3rd of 2025. It was titled Pandora's Cluster of Galaxies. We'll be back again tomorrow for the next picture, previewed to be IOMN. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.